Okay, so now we're going to transform cotangent. And again, basically I'm going to be doing the same thing we've been doing. So k plus a cotangent of bx minus h. Okay, so again, this is my k, that's my center line. So my center line's at y equals 3. This is my amplitude. Well, cotangent doesn't have an amplitude, that's my vertical stretch. It doesn't have an amplitude like sine and cosine do. This is b, which might change in period. So my period equation is 2 pi over b, and in this case b is 2, so this is 2 pi over 2, which is pi. So we have a horizontal compression here. Okay, and we have no shift. So we'll start off by drawing our parent function for cosine or cotangent. So yesterday we went over this is tangent and this is cotangent. So this is what my cotangent parent function looks like. So we come over here, we have our asymptote here, and then our asymptote here at pi, asymptote at 2 pi, 1, 0, negative 1, 1, 0, negative 1. So here, this is my cotangent parent function. Okay? Alright, so the first thing I'm going to do is deal with my change in period. Okay, and this is part of the reason why I don't normally draw parent functions for tangent and cotangent, is because it tends to get messy. Because now what's going to happen is all of my function is going to be horizontally compressed. It'll start at 0 and end at pi. Okay, which means this vertical asymptote is now here. So my function is going to end here. Okay, which means right in the middle there is a asymptote. Then my zeros compressed into the middle of those. So 1, negative 1, 1, negative 1. So this is my horizontally compressed function. Okay. Next, I'm going to vertically compress it. My amplitude or my vertical compression is by 1/2, which means that my zeros stay the same, but this point that was at 1 is now at 1/2, and this is here at 1/2, and this is at 1/2, and this one's here at negative 1/2. So what's happened is it's been vertically compressed. And of course, you don't have to do anything to your asymptotes because it's a vertical transformation. Anytime you have a vertical transformation, the asymptotes aren't affected. So now, the last transformation, 3, my center line's moved to 3, which means everything's moved up 3. So again, vertical asymptotes don't move, but this point is going to go up 1, 2, 3 to here. So I got this point here and that point there, and this one goes up 1, 2, 3 to here, and then I have this point here and that point here, and that means that this is my new cotangent. And you see how messy this is? So just be careful when you're doing these to make sure that you can read your graph.